Welcome to day 2. We'll look at some more distributions, a bunch more. We'll start with the world's easiest, most boring distribution. This one represents probability 1/6. 1, 2, 3, 4, 5, 6 times. What do you think that's modeling in real life? A dice or a die, yep. So if you have a die, all the sides are supposedly unbiased, would all have the same, so that what you would do is you would say the probability function is going to be 1, because that's what all of them add up to, divided by the number of sides. And that's the normal distribution. Okay? Then if you go to, the discrete random. Not too interesting, not too boring either. This one is going to annoy you because look at this formula. Doesn't that formula look complicated? Doesn't it look like it'd take like years to learn? Or at least 10 minutes, right? Well, all this is saying is the following. I succeed or I fail. That's what it says. Because there's two values for x in this discrete distribution. 1 or 0. And 1 means that we win. And what do you think 0 means? Yeah. In today's day and age, you don't say lose, you say non-winner. Slightly deficient of winning is what you would say. All right, so here's what happens. So if x is 1, look at what happens in this formula. If you put a 1 in here, 1 minus 1 is 0. 1 minus p is the same as q. What's q to the 0? 1. And p to the 1 is p. So if x equal 1, you're going to get probability p of success. Look what happens if x is 0. If x is 0, or k in this case is 0, now the probability is to the 0 is 1, and q is going to be to the 1 minus 0. So this is going to be equal to 1 times q, or q. That's loss. So p is you win, q is you lose. That's a pretty boring summation, isn't it? Yeah. It's making a one trial situation into a distribution of all the possibilities, win or lose. And let's go to the next one. You have yours blocked off, don't you? The white, yeah. The binomial is the one that you're most familiar with. This has n trials. So with the Bernoulli, how many trials did we have? Just one. Just one. You either win or you lose. This, you could flip that coin 50 times. And then what we're going to predict is because you can have many different combinations, you're going to have a little bit harder time finding that probability. One of the rules is that there's n trials, and independent means, like most gambling, you win one time, it doesn't affect your winning the next time. Or if you lose one time, it doesn't affect your losing the next. And here we're looking at completely independent. And then the other thing I like to add to this is you, in each case, win or lose. You can't win-lose or lose-win. You win or you lose. Can't partially lose. All right? So with this is the one that we've seen before. N, choose x. P to the x, q to the n minus x. That's the one that we had in the last test. Okay? And we also talked about these, the expected value. If you have 50 tosses of a coin and the probability is 1/2, how many heads would you see in 50 tosses would you expect? N times p. And then for variance, it's NP times Q. And I'm not going to prove it here, but we could prove it. So I'm going to cover this up. as it should be. All right, it says a bag contains 3 red spheres. So let's go 3 red and 4 blue. And they're all identical shape. And we're going to have 8 trials. Okay. Find the probability of choosing up to 2 red spheres. So what's the probability of getting a red? 3 out of how many? Not 4. 7, right? There's 7 total spheres. Probability of one time it's 3 out of 7. Okay, what's the probability of no red? 4 out of 7. What do those two have to add up to? That's 7 out of 7. It's the rules for binomial. They have to work out. So find the probability of choosing up to 2 red. So here are the possibilities. You could have 0. You could have 1. You could have 2. I think they're including 2, aren't they? Up to? Yeah. So let's do probability of 0 first. So we're drawing how many times? 8. And then each time we draw, we put it back. And we're choosing, we want to see 0 reds. Red probability is 3/7 to the 0, because we don't want any reds, times 4/7. We want to have 8. Yeah, that would be no reds. For 1 and 2, you go ahead and set those up. 8 choose 1, 3/7 to the 1, 4/7 to the, now it's only 7. 8 choose 2, 3/7 to the 2, 4/7 to the 6. Powers add up to the same. And what did you get for a total? Let's see. Point what? I liked it. 0.259 is what they had. Is that all right? So that's binomial. That's the one you're familiar with. But the one you're not familiar with has to do with shooting baskets. Sometimes the number of trials is not finite. And so there's a couple ways that you can look at probabilities that aren't finite. One is to go until you win or lose. You know, maybe you're looking at when you go bust as far as gambling. But go until you win is a really interesting one. So let's say the probability that Anna got hers in to the basket was, I'm going to say 1 out of 20. I'm not being mean, I'm just, we're going to say it's 1 out of 20. That's not very nice. I'm going to say 1 out of, well, took 6. So let's say 1 out of 6. But it's 1 out of 6. But what happened in her situation? For it to take n equal to 6 times, what happened the first 5 times? You missed. So it's 5 out of 6, 5 out of 6, 5 out of 6, 5 out of 6, 5 out of 6. And what happened on the 6th time? 1 out of 6. So what happens is that the more you play this game, what happens to the probability? Smaller or larger? Well, this is less than 1, so that's going to shrink this. This is less than 1, that'll shrink that. Won't this just keep making it smaller and smaller and smaller? So the more it takes, the smaller the chances it's going to get. So look at what this is. This is 5/6 times 1/6. But what power is this for 6 tries? That's 5, and then on the 6th try, you win. Okay, so poor Megan. Okay, this is going to be, let's say hers was 1/6, 2. But here it took her 11 losses, and then on the 12th one, she made it. Let's look at mine. So don't feel bad. All right, so that's the geometric distribution. Love this one. It's cool because it really does, you can see it working in a real life situation. So in a wheel that spins, let's say that we have 150 numbers on the wheel, and we're looking at multiples of 7. That would be 7, 14, what else? 21, 28, 30, 40, 49, and that would be it. So there's 1, 2, 3, 4, 5, 6, 7. So the probability of success winning would be 7 out of 50. All right? In a spinning wheel game, you win if you get a multiple of 7. Assuming the game is fair, find the probability that you win playing 4 games. So this one, x equals, I'm going to say n. N is equal to 4. Okay? So that's going to be 7 over 50. Lose, how many losses will that be? How many times will we lose? 3, and then on the last one, oh, and I didn't write this correctly, right? This is 43, right? I lose 3 times. And then on the last one, I win. 7 over 50. Those add up to 4. Okay, how about after no more than 3 games? So what are you talking about there? Probability on the first, probability on the second, probability on the third, right? What's the probability of winning on the first? 7 over 50. On the second, it's 43 out of 50. Lose, and then you win. And then on the third, it's going to be 43 squared times 7 over 50. So if you were to look at this formula, and it's a sweet one, it's just going to be lose to the n minus 1 times, what are you doing on the last one? You win. Yep. That's it. Well, it says after more than 3 games. For B? So, yeah, and we'd add these up. Thank you. You'd add these. And you'd get whatever that sum is. Now, after you get that sum, how would you find this part C? 1 minus. That's nice. That's not too bad. All right, are you ready for the hard one now? This is the hard one. Now, one way to play is that you play until you win or play until you lose. But most games are not that way. There's several wins, but the last player has to, if they're a winner, the last player has to win on the last game, right? So what we're looking at in most situations is X is your number of trials, and then R is your number of wins. Like, you're not playing until you win once. In a game of ping pong, you go until you win how many times? 21. But you could lose 20 times, couldn't you? You could win 21 to 20. Actually, if you have to win by 2, let's say 19. Well, we're going to do one that has 19 in a little bit. The idea there is that you have to lose. You have to win 20 times, but it doesn't matter how you win them. So think of it this way. Let's say you had to win 3 times. Let's say your X is equal to 3. So let's look at the possibilities. You could win 3 times in a row, and you're the winner, right? But what else could you do? You could win, lose, win, win. You could lose, win, win, win. You could win, win, lose, win, right? What else could you do? Unfortunately, you could lose, lose, win, 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 and you can see there's a lot of possibilities here, right? Lose, win, win, lose, win, and you could keep figuring these out. Wouldn't it be nice if there was a formula for figuring that out? There is, there is. And what you would do is you would look at the number of games that you would have to play, and then you would say, okay, if I knew that number of games you had to play, then what we would do is we would say you can look at x minus 1, whoops, x minus 1, and then you can choose r minus 1 because you want to win on the last one. But what happens before, it doesn't matter. So you can look at all of them except the last game. So it's the number of trials minus the last game, the number of wins minus the last game. You find out how many combinations there are. For 5 games, it'd be 5 minus 1, and then you could have 5 minus 1, and you have to win 3 games, 3 minus 2. So this would be 4, choose 1, which is a total of 4. And there's 4 ways that this could be. All I had to do is put them in one more spot, and I would have had it. But anyway, we're going to do that with, here's the formula. And the formula is really, really simple. It's just the number of times you play minus 1, the number of wins you want minus 1, p to the number of wins you have minus 1 times q to the x minus 1 minus r minus 1. Minus a minus will be plus. Well, what happens to these 1s? They cancel, and so you get x minus r. That's nice. But what has to happen on the last event? You win. So this is p to the 1, and this is p to the r minus 1. What happens to p to the r minus 1 times p to the 1? It becomes just p to the r. And this is the probability of winning with this one. And this is way more useful. This is like tennis matches and most games that you would play. So let's play badminton. How many of you play badminton? What's the name of that little thing they hit? Yeah, that's the weirdest name ever. Okay, on each point in the badminton set, Dan has a probability. Notice my favorite number coming up again, point 52. All right, suppose they play a set of 21, so your x is equal to 21. Find the probability that Dan wins the set, 21 minus 19. So it looks like r is going to be 20 because 20 minus 1 is 19. So then what you would do is you would say the probability that Dan wins is going to be 21 minus 1. And he's going to win how many? Oh, wait, I didn't say that right. How many games would they play? This should be 21. I did this wrong. X is how many serves? 40. My mistake. And this is 21. There you go. So this will be 40 minus 1, 21 minus 1. And the probability was 0.52 to the 21 wins, and 0.48 to the 40 minus 21. That's 40 minus 21. 19? Yeah, that's how many losses there were. Okay? And so if you crank that out, you will get 0.0658. So not a very 6% chance of winning at that score. There's other scores you could win too. How we doing? Kind of interesting. And then there's mean and variance. All I'm going to tell you is that there's a formula of these that you can use. These would be given to you. We're not going to prove those here. All right, go to the assignment.
Hi, we're in Minnetonka High School. As you know, we are now going.
All right. So real quick, let's just show how you would do these. We'll do more of these tomorrow. In a game of 10-pin bowling, Zoo has 29% chance of getting a strike, and they're going to go 4 bowls. So if he gets it on the 4th time, what happens for the first 3 times? Lose. So that'll be 0.71 to the 3rd. What happens on the last time? Win, 0.29. Yay! All right, how about this one? Find the probability that Zoo will take 7 to score 3. So forget about the 7. 7 minus 1. In the first 6, he's got to score 2, right? Find out how many those are. Probability of winning is still 0.29. And that's 2. He needs a score of 3. And 0.71, he's going to have a total of 7 minus 3 is 4. And we'll do more of that tomorrow. Thank you.